friend, you are welcome back to my channel. In today's video lesson, we shall be learning about image characteristics for concave mirror and convex lens. So without wasting time guys, we'll be getting right into it. Now assume you have here a concave mirror, okay? This part is painted, okay? So this is the refracting or the reflecting side. Now then you draw the axis through the pole of the mirror. This point where the principal axis pass through is P, and P stands for the pole, okay? Be it for a mirror or a lens. Now beyond that we have what is called F, okay? F stands for the principal focus. The principal focus. Like you can see, I said capital F, alright? Now beyond that you have another important point called C or 2F. Now I will explain. This C stands for something. It is called the center of curvature. That is what C stands for. Now let me explain. Why did I say C or 2F? Now if you are talking in terms of mirror, you use C. But if you are talking in terms of lens, you use 2F. So either ways, we are talking about the same thing. C or 2F refer to the same thing. Now assume this is what we have. Now the question before us here is, how will a certain image look like if an object is placed here? Call it position 1. What if the object is placed at this point on the principal focus? How will the image look like? What if the object is placed here between C and F? How will the image look like? What if the object is placed at position 4 at the center of curvature? How will the image look like? Or what if the object was placed beyond C? Beyond C, this is C. How will the image look like? And what if you now want to extrapolate and position the object at 6, where 6 is infinity? Where 6 here is what? Infinity. If you put an object at infinity, how will the image look like? Guys, it's very interesting. Let's get into it. Now we'll be using a table format, okay? Let's make use of a table format. We'll draw the table like this, alright? We'll draw the table like this. Here we call it object position. Object position. Here we will call it image position, okay? Image position. And lastly, we will call it image characteristics, the purpose of this class. Image characteristics. So guys, we'll be looking at these interesting things, okay? Just stay put. Let's get into it. Now for the first position, what do you observe? For the first position, an object was placed between F and P. Between F and P. Guys, the question before us is, where will the image be? Take note, when an object is placed between F and P, for a concave mirror or a convex lens, the image will be formed behind the mirror. Behind the mirror. Behind the mirror or behind the lens. And mind you, not just any mirror, but concave mirror, and not just any lens, but a convex lens. Now, how will the image look like? We have agreed that it will be formed behind the mirror. How will it now look like? The answer is VEN. VEN. Where your V here stands for virtual, and then your E here stands for erect. And not just that, you have M. M here stands for magnified. So the image form will be virtual, the image form will be erect, and the image form will be what? Magnified. So that is for that when an object is placed between F and P. So let's progress. Position 2. What if the object was placed exactly at the principal focus? Where will the image be and how will it look like? So at F, our image will be formed at infinity. At infinity. At infinity. I want you guys to be observing the train as we progress. Be observing the train. Now, how will this guy that is formed at infinity now look like? How will the image look like? It will be re-inverted and magnified. What did I say? Re-inverted and magnified. So I will add it. Re, We have already written for V, E, and M. So let's just add arrow. Arrow equals re, okay? Then I equals what? Magnified. No, sorry. I equals inverted, sorry. I equals inverted. And M, like we know, equals what? Magnified. Now let's go to position 3. When an object is placed between C and F, position 3. So right, between C and F, how will the image, for where will the image be? Where will the image be? The image will be formed beyond C. Beyond C. So observe something. You know we are moving in this way. Do you notice that we are moving in this direction? In terms of object position, we are moving in this direction. But you notice something. As we are moving away, it's like, observe something. An object was placed here, the image was formed behind the mirror. An object was placed here, the image was formed what? At infinity. Just keep observing the trend. I will draw it when I'm done. Now, when an object is positioned between C and F, we agree that the image will be formed beyond C. That means beyond this point. And then how will the image look like? It will be re-inverted and magnified. Now, what if, number 4, the object, for position 4, the object was placed at C. At C. Exactly at C. Where will the image be? Answer. The image will also be at C. Take note of this important point. When an object is at C, the image will also be at that same C. And not just that. How will the image look? How will the image look? The image will be arrow IX. Arrow IX. Why did I say so? Where your X equals same size. Same size. That is, the image form will be real. And the image form will be inverted. And that same image will have the same size as the object. And it will be formed at the same position as the object. Do you get that? Now for position 5, we agreed that position 5, the image or the object was placed beyond C. Object being placed beyond C. Where will the image be? Now when the object is placed beyond C, the image will be between C and F. Observe something. Between C and F, images are beyond C. Beyond C, images are between C and F. Now, what will be the image characteristics? Observe something. This image was, first of all, initially very large at these 2 points. Now, downward, it's like it's now coming to its normal size. Now, after it has attained its normal size, what do you expect it to do? To become what? Smaller than its normal size, is it not? So, the image characteristics now, after attaining same size, will now be ROID, where your D stands for diminished. Diminished. So the image is no longer magnified, or the image is no longer having same size as the object, but the image is now what? Smaller. So we say diminished. And lastly, for position 6, they said at infinity. What if the object was placed at infinity? Guys, where will the image be? Where will the image be? It's very easy to get. Remember we had this. So when the object is now placed at infinity, the image form will now be at position F, the principal focus. And guess what? The image characteristic should be ROID. So it will become very smaller than in this case. So what do you observe? Tell me, go through all this. What do you observe? As we are moving the object away, as the object was kind of running away from the mirror, it was like the image is running towards the mirror. So the farther the object actually was from the concave mirror or the convex lens, the closer the image was to the concave mirror or the convex lens, and the smaller the magnification becomes. I hope that is clear. It's very easy to understand. Go through it. As the object was going further from here, it becomes at infinity. We observe that the image that was at infinity now becomes at the principal focus. As the object was going away, the image was approaching the mirror. And the magnification decreases. So it's very easy to cram. This is all about image characteristics for concave mirror and convex lens. And I trust you find the lesson helpful. I will see you guys in my next video.